I want to welcome each one of you to this particular session on overview of data collection, data analysis, and research. I have so many slides. I don't know for how long the Zoom will last, but I'm sure it will be more than 45. So inshallah, we'll be able to finish in good time. So based on the requests, what are we expected to discuss? We are expected to discuss data collection processes as it is done in scientific research, and brief description of how basic data analysis can be approached and what are the common statistical tests that are used for the data analysis. Right? So, because we are using Zoom, sometimes I cannot monitor some things. Okay. Now, going to the first slide, I have a popular saying from one of the statisticians of our times, Bayes. He said, no statistical technique will ever yield a good result from data of dubious quality. What does it mean? It means if the data is not of good quality, no matter what you do, you will not get a satisfactory analysis. So maybe as we go along the slides, we'll be able to identify why these statements are relevant. So by way of introduction, this is the outline of the presentation. Introduce the topic, like briefly take you to the basics about data, then data collection methods in scientific research. Now, this could be qualitative data collection or quantitative data collection, as the case may be. Then I will compare briefly the two researches, qualitative and quantitative, with regard to the SLO. That is the methods, data collection methods, and maybe the analysis. I will make a brief mention about it. Then we go into the main body of the work, which is the basis of choice statistical methods. And see how we plan ourselves, how you do data entry, how you do data checking, how you clean your data, how you analyze qualitative studies. But this one will be a brief mention because mostly in medical sciences, we use quantitative studies. However, the world is changing. There's a need for physicians to be exposed to qualitative studies. So we make a mention of that. Then we see how some analysis are made based on observational studies. Then a brief mention about randomized controlled trials, survival analysis, and meta-analysis. Okay. Now, introduction to data. What is the data? A data are a set of values of qualitative or quantitative variables about one or more persons or subjects. Of course, long we say what is a variable? A variable means any measurable entity. So if we say data is a set of variables, which is either quantitative or quantitative. So what is data? Data are simply units of information. And is usually measured, or is collected, or is reported, or is analyzed. Okay? And the whole idea is to create visualization in terms of graphs, tables, analysis, and information. Now, to those of you that are just coming into medical sciences, data could be quantitative or qualitative, as I mentioned in the introduction. Quantitative, the word quantitative means numbers, means measurable observations. Qualitative data is the data that can be arranged into categories based on some personal traits. For example, when you want to take data about the gender, it is a qualitative data. Okay? So you cannot measure gender. You can only segregate the two genders, male and female. And many times they are mutually exclusive. So the only thing you can do is you can just allocate a number to differentiate male from female or female from male. So that's qualitative data. So, but in reality, qualitative data involves more details about reasons, opinions, like it tells you details about question like why, when, and how. These are open questions which require explanation as answer. So this about the qualitative data. Now, what is data collection? Now, the data collection is a process by which the researcher collects the information needed to answer a research problem. Of course, those of you that have had their epidemiology post or course, and those of you who have had their public health course, you've seen how we collect data. And before we collect data, we must identify a problem, a research problem. And we develop a research hypothesis. Okay? Now we go to the field using a defined methodology to collect the data. Now when we collect the data, we now analyze it. So data collections means you are collecting information which is needed to answer a particular research problem. Now, of course, having collected the data, or in the process of collecting the data, what do? We first look at our research problem. Which data are we going to collect? How are we going to collect that data? Who and who are responsible for collection of that data? And when that is the time are we going to collect the data? Now, these are questions we have to ask ourselves whenever we are faced with data collection during research. Now, it is important to know that the purpose of collecting data, as I mentioned in the last slide, is to get an information. Any data that is not treated and does not generate information is useless. So the purpose of having data is to obtain an information that answers a research question. Secondly, we want to use data to keep records because we use the data for our planning. So we can use data for our decision making. So the authorities and policymakers make use of data to make decisions about important issues of life. An example is, let's say, we have high prevalence of non-communicable diseases in the kingdom. So this will give us an idea of what authorities are doing to address that problem. So that's one of the advantages of having data collection. Then, of course, for knowledge, you pass the information to others. Okay. I hope we are together, and I hope I'm not being very fast. Now, essentially, there are two types of data: primary data and secondary data. The primary data are those data which are collected for the first time, and they are original. The first time you are collecting. However, we have another type of data called secondary data. This type of data has been collected and kept somewhere. If you are coming to use this type of data, then definitely it is secondary data, because perhaps you do not even participate in its collection. So, data collection methods. Data collection methods depend on the type of research. Methods you follow I mean, doing a quantitative research may be different from the methods you follow when you are doing quantitative. Now, both qualitative and quantitative methods are important. Now, quantitative approaches are important in solving many types of research problems. But the qualitative research is much more appropriate in addressing the type of questions you raise in your research. For that reason, I try to highlight some few differences between qualitative and quantitative research, but with more emphasis about data collection method. Now, of course, I told you at the beginning, when you have to go to the field and collect data, you must have had your research question or research problem, which you want to answer. So the aim of your research many a times differs from qualitative and quantitative research. For example, the aim in qualitative research is usually to find out or to explore your respondents' experiences about the world, trying to generate theory. We call it exploration. But in quantitative data, many a times, the aim of the research is to determine causal explanation. For example, does smoking causes lung cancer? Does use of insulin bring about insulin resistance easily? So in quantitative research, we try to find causal explanation. And this is usually done by different types of studies. And we sometimes generate hypotheses and even test it. So this goes to the aim. Now, the approaches between the two types of researches when it comes to data collection are different. The approach in qualitative study is broad-based, process-oriented, and is contextual. But in quantitative science, we are more well-focused. We are much more product-oriented. We are more precise. There's no room for much mistake. Now, of course, data is collected from the population, right? Now, because of some reasons, you cannot cover the whole population in your study. You cannot go to every household in Bisha to collect data. So you need to have a sample. Now, sample, what we mean by a sample is a subset of the population, a portion of the population, which we assume to represent whatever is contained in the larger population. So we usually do our research on the samples. Now, coming to our main point, which is data collection, which is our point of discussion today. There are different types of data collection methods in qualitative study, which is almost different from what we do in quantitative studies. So based on your study design and methodology, you follow these collection methods. For qualitative studies, we do an in-depth interviews or a focus group discussions. A focus group discussion is like when you have a group of people that are homogeneous in terms of their social status, in terms of their experiences, between 8 to 10 in number, and you have developed your questionnaire. What you do is you ask them questions and they answer based on their experiences while you are recording it. Now, an in-depth interview is like somebody has a particular experience, it's well experienced about a particular matter or subject of interest. You now go to him to interview him to find out some of the answers to your research. For example, you want to find out about performance of medical students. One of the best things you do is you go to the dean and ask him, and he'll be in a good position to tell you what the performances are across the levels. So that's one of the methods of data collection in qualitative studies. Another method is fieldwork, use of document and video works. Now, in quantitative study, we use standardized interviews, which might have even been pre-tested before coming to them, and they are well structured. Now, and coming to the analysis, we use different analysis methods. If the study you're doing is qualitative, I told you, of course, the data you are collecting is qualitative. So you need to do some thematic analysis or content analysis or ground theory or ethnography as the case may be. But in quantitative science, usually the analysis is statistical. And this is where most of our interest lies. Good. Other similarities or differences are there. You can go through it. Now, coming to our data analysis, quantitative, which is the main focus of our discussion tonight. Now, the correct choice of statistical method ensures that you have the right answers provided by the right questions. So that means if your method is strong enough, your research will be very sound. Your results are likely to be accepted by journals and enhance the reputation for you, the researcher, and for the institution you are working. So this is one of the ways in which how correct choice of statistical method support a researcher. Now, if your methods are okay, are very sound, if you write proposal either for grant or for dissertation or for degree programs, they are easily acceptable. And most importantly, choice of statistical method help you in providing evidence for medical practice, especially those of us that are working in the health sector. Now, how do you choose which statistical method to use for your data analysis? This is the main focus of this lecture tonight. Now, the basis of choice of statistical method to use for your research depends on so many factors. One of the factors is study design. The study design determines which statistical method you use to analyze your results. For example, if you're using either cross-sectional study or you're using comparative study, it is also cross-sectional, or you are using cohort study, or a case control study, or a randomized control trial, or meta-analysis. It depends on the study design. Another thing, when you want to find out which statistical method is effective for your research, you need to look at your research question. Because your design is always based on the research question you want to answer. The next step, another factor or the next factor for the basis of choice of statistical method to use is the nature of your data. Because if the data is qualitative, use quantitative methods of data analysis. But if it's quantitative, definitely you have to use quantitative methods. Now, if quantitative, you also need to consider the distribution of the variable and sample size. I don't know if bulk of the audience don't know if the bulk of the audience are coming from College of Medicine, but I'll try and make it as simple as I can. So you also look at your sample size and the distribution. Now, let's do some basics. Let us do some basic reflection about what we know in the past. Types of measurement, scales of measurement. We said if we want to use a good statistical method, we need to know the type of data we have. And that data is usually measured on 4 basic scales. The nominal scale, which we believe is the lowest measurement of all W we use. Remember that usually it's dichotomous, but it can be more than that. Example, marital status, gender, assumption, true or false, as the case may be. Now, if the data is on ordinal scale or ranking scale, that is places the variable in order according to their size or quality, like small, big, bigger, or mild, moderate, severe, or uh, 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 intern, specialist, consultant. As the case may be, you are ranking. The data is being ranked. This is more of a qualitative data, and usually depends on how you collect the data. It shows the ranking of an item from the highest to the lowest score, from the lowest to the highest score, as the case may be, and is usually used to capture qualitative data. Now, the next thing is, let's remind ourselves about the interval scale or the rating scale, which shows the distance between two measures, okay, and a fixed difference of 6 meters. Example of Richter scale. And the last scale of measurement, which help us to know the type of data we have, before we even think of the type of analysis we are going to have, is the ratio scale. It is the ratio scale. So the ratio scale is has all the properties of the nominal, ordinal, and the rating scale. And it has an absolute 0 point, unlike the interval scale, which doesn't have. So it can do all the calculation. Now, this is just a reminder about scales of measurement of the data before we go into the main thing. Now, in choosing your statistical method, which statistical method to use to analyze your data, you have so many options. I'll give you an example. It depends on your hypothesis. Do you want to find a difference between observations, or you find out a relationship between observations? You know, in statistics, we usually say, okay, there is a statistical difference between people that attend public schools and those that attend private schools. You know, we are trying to find out a difference between two phenomena. But sometimes it's like you want to have an association. Maybe you want to find out GPA. Student GPA is associated to his attendance in class. So there are different, hypotheses you want to test. So depending on that, that is the first thing that comes to the mind. Now, second thing that comes to you when choosing statistical data, analysis or test to use, is what I mentioned in the last slide, the type of data. Is it nominal data? Is it ordinal data? Or is it continuous? Now, the continuous data is divided into interval and ratio scale. Now, if your data is continuous, you now look at it as if you fulfill all the assumptions for parametric tests. Usually parametric tests have the assumption is usually done when the data is normally distributed. You remember the normal distribution? Normal distribution curve. Now, if the data is normally distributed, that means your data will build the assumption of parametric test. That is the next thing you ask yourself before you go to the statistical test. However, if the data is not normally distributed, that is asymmetrical. For example, you have extreme values or you have skewed data. Then you use the parametric tests. Okay? So use the non-parametric test. Now, assuming the data is normally distributed, you now look at the way the process was done. Is it a paired data? The simplest way you can understand a paired data is like, if you know the before and after study. For example, you want to have a study about the blood pressure or the blood glucose level. You can take it when somebody is at rest. Then maybe you ask him to go and do some exercise. Then you take it for the second time. That is a paired data. That's an example of paired data. Unpaired data is like when you have two data together. Maybe you have a group that is exposed to a particular event. Okay, then you have a control group. That is an unpaired data. Okay, so now coming to the choosing of statistical tests. If you are using the parametric and the data is normally distributed, you now ask yourself, is it paired or unpaired? If it is paired, then you use t-tests. Now, if it is unpaired, you use unpaired t-tests. However, if the data contains more than two groups, then you go ahead and use ANOVA, Peter Mitchell ANOVA. If the unpaired, the continuous data is unpaired and it has more than two groups, then you go ahead and use one-way ANOVA. Now, this for continuous data. Now, I told you continuous data could be on the rational or, ratio or on interval scale. Now, imagine your data is ordinal, which is ordered, in terms of category. Okay? So, the same assumption. Now, your data is ordered. What do? You look at it. Is it paired or unpaired? If it is paired, then of course, the best analysis for you is to use what called sign rank tests. But if it is unpaired, the easiest way to do is to use Marmotini U-test. However, that is when the group of the paired and the unpaired are one group. If you have more than two groups, let's say 2, 3 plus, then you have to go further. If the data is paired, you use Prideman test. If the ordinal data is unpaired and it has more than two groups, then the best statistical test to use is Krukas-Wallis. Now, that's for the ordinal type of data. Don't forget, we also have the nominal type of data. So even the nominal type of data, it could be paired or unpaired. Paired like before and after, unpaired like when you have cases of control. That's unpaired. Now, if you have a nominal data and it is paired, the best statistical test to use is McNemar chi-square test. McNemar chi-square test. However, if it is unpaired, then you can use our conventional chi-square test for homogeneity. This has been the case. Now, this for the differences. Same thing applies for the relationship. You look at the data, is it nominal, is it continuous, or is it ordinal? If you are trying to find an association or relationship between two variables, and your data is continuous, and assuming it has normally distributed. Even if the data is not normally distributed, there is a statistical way you can do log transformation. Okay, but we'll come into that much later. So if the data is normally distributed and is continuous, then you want to determine relationship between two variables. For example, you use Pearson correlation or you use linear correlation. Correlation tell you usually a continuous data that tells you any relationship between two variables with a value of R. Okay. Now, if the data is not normally distributed, it's skewed, like the ordinal data we used to have. Most ordinal data are skewed. Then definitely, instead of using Pearson correlation, we go ahead and use Spearman correlation. Now, if you really understand this slide, it has given you the leverage to navigate on which statistical test is appropriate for your data. I will not waste much time. If you have any questions, just hold it until we finish. Now, your analysis plan as a young scientist, upcoming. What are your plans? What plans do you have for analysis of your data? Now, there are so many statistical packages available for data analysis. For example, I'll give you the R, BNeTab, SPSS, Stata is there, and many more. If your data is not good, you can run an endless incorrect analysis to infinity. So you must know how to use those statistical how to use statistical software. So what are your analysis plan? You have collected your data. The first thing you do is you look at the response rate of your questionnaire. Maybe you sent out 100 questionnaires and only 75 came back satisfying your criteria. So your response rate is 75. You need to identify the socio-demographic features or simple characteristics. Now, the best way to do data analysis is to do analysis based on your specific objectives. That is the best way. However, there is a catching point here. Before you even jump into analysis, the first thing you do is you have to look at your data. Is it correct? Is the data correct? Because there are errors that occur during data collection, okay? Or during the entry of data into Excel or into SPSS, okay? So you need to check your values and see they are in compliance with what your questionnaire is requesting. So this is usually done through what we call data checking or data cleaning. Now, I think for those of you that have attended my class in the past, we have done some practicals about data cleaning. Usually it's done after entering the data. The whole idea is you should be able to identify errors in your data. For example, you have a qualitative data of blood group coded as 1 is people with group A, blood group, with group B, we code them as 2, 0, code them as 3, AB. Now you can see 1, 2, 3, 4. They are distinguished. On my data, if I see 1, I know it's B. If I see 4, I know it's AB. If I see 9, a code given is missing value. Okay? Now, if you are running the frequency of your data, for example, and you discover that part of this entry, you now have 5, 6, 7, 8, you know there is something wrong. You have to check. For those of you who do not understand it very well, your entry should be between 1, 2, 3, 4, and 9. There should not be 5, 6, 7, and 8. If you have 5, 6, 7, and 8, you know something's wrong. Another way of revealing errors, for example, if you're going through an Excel data or SPSS data, you discover that this is a child. You say it's a child, yes. And how old is this respondent? You say it's 50 years. How can a child be 50 years? So these are some of the ways you do data cleaning to ensure that your data is ready. Now, for quantitative continuous data, we use range checking. For example, the age range, or let's say it's the level of hemoglobin. We have a range of hemoglobin level for males and females. Okay, so you use the range to check if the data is quantitative and try and identify some misplaced decimal points. For example, you want to have an entry of a 20-year-old and mistakenly maybe the data entry clerk made it 200. How can you have somebody who's 200 years? You know it's not realistic. However, that does not mean there may not be outliers. Yeah, in every data collected, there are outliers. Outliers are extreme values. If you remember our lecture on standard normal curve, you know, we say there are those people that are at the extreme. Okay? 68% lie within one standard deviation from the mean. 95% lie within how many? Standard, two standard, yes, two standard deviation from the mean. That's 1.6. Now, 99% lie within 2 standard deviation. So if you are entry, you know your entry column contains age, and the age is in numbers. And you see somebody with an age of 200, you know there's a problem. Now, look at the data again and go back to my first statement. Does the data look normally distributed? Okay. Many types of statistical analysis assume a sample or a data collected from a sample from a population is normally distributed, which is not. So it's always important to determine that this assumption holds or is plausible. Otherwise, instead of doing conventional tests, you have to do non-parametric tests, or you have to do log transformation of the data to change it from asymmetric data to normally distributed data. And there are so many ways you can also do that. You can check for the normality of the data using histogram, using superimposed normal curve, normal plot, or using Shapiro-Wilk test, as the case may be. Okay, so don't assume because you have gone into the community, collect your sample, that the data you have collected is normally distributed. Now, until you subject that data to the test of normality. And one of the ways we test the normality of the data is to develop the histogram and superimpose normal curve, or you use the Shapiro-Wilk test for normality. Now, if you remember the last thing I spoke about, I also spoke about your study design. Your study design matters in the type of analysis. Okay? Because you are using cross-sectional descriptive study. As a researcher, you need to know you are the response rate of your questionnaire, how many you approach, how many agreed to participate, how many responded. You need to tell us about the socio-demographic characteristics of respondents, their sex ratios, their ethnicity, education, occupation. All these are part of socio-demographic features. The age. Whenever you have collected information about the age of the respondents, you need to give us the mean of the age and the standard deviation, especially for a normally distributed data. Then we need to also know the median and the range, okay, or the median and the interquartile range, if the data is not normally distributed. Because remember, we always say if the data is skewed, the best measure for the central tendency is the median. Now, you need to also give us the prevalence of characteristics with 95% confidence interval. For example, a disease, we need to know its prevalence and what are the range, okay? In terms of confidence interval value. Now, if the variable is quantitative and normally distributed, always don't forget the fact that part of your data analysis means you have to tell us the mean, standard deviation, and the 95% confidence interval of that particular data. Hypothesis testing, quantitative. Now, you all know that cross-sectional studies generate hypotheses. Okay? They generate hypotheses. Okay. So, what we do is you may be interested in testing the finding for your study. For example, you took some biometrics and some physicals like pulse rate, BP, systolic and diastolic. Now, for a normally distributed sample, one sample which you assume or you have tested to be normally distributed, you can apply your t-test or your z-test as the case may be. You know, many times, depends on the size of your sample. Okay? You remember the student t-test when the sample size is less than 30. When the sample size is more than 30 or 40, as some school of thought may say, okay, standard deviation, you don't need to use t-test. You have to go and use the t-test. Now, for a data that is skewed, non-parametric test, such as the Wilkinson test, can be used. However, if you still want it, that is information. Now, remember, this looks like the summary of what I give in that slide, which is graphical. The data is paired and was measured on the same group before and after. Paired t-test can be used. Okay? And of course, if the data is skewed, you can use match pair or sign rank. We'll call it sign rank test. Now, testing for association between socio-demographic factors and disease. We usually do this one using contingency table. And one of the commonest tests we use is chi-square test. Okay? Sometimes, if the data satisfies the condition on which you have to apply this particular statistical test. Now, in some cases, you may not be able to do the chi-square because maybe there are some problems. You have to do what you call Yates correction. The computer and what do you call it, the statistical software can do this one for you. Now, if one of the variables is ordinal, okay, you use chi-square for 2x2 contingency or chi-square for trend. However, sometimes the Yates correction will help you to accept the chi-square value as if it was the original way that was done. Now, another way of transforming the data to be able to do a chi-square test without any problem is when you have to apply Fisher. When you have to apply Fisher exact test. Fisher, usually, when the chi-square criteria is not fulfilled, I'll give you an example. If the expected value from one of the cells is less than 5, in that case, you cannot use chi-square. So you have to do either Yates correction to do the chi-square, or you opt for another test, which is called Fisher exact test. So these two, Fisher exact and the Yates correction, helps in trying to solve your problem when you're trying to make association between socio-demographic features and disease status outcome. Can you see my slide? Can you see the slide? Can you see the slide? I don't know where I entered. Sorry for the interruption. So chi-square tests, if you fulfill the criteria, the data fulfill the criteria, you can do chi-square. If it doesn't fulfill, you can do Yates correction or you opt for Fisher exact tests. The next thing is cross-sectional studies, which are the simplest and the most common type of study we do here in the college. When you have cross-sectional studies, one of the things we need from your data are similar to what we said in the other slide. Your response rate, socio-demographic characteristics. If it's a comparative cross-sectional study, you have to show those pictures for the two study groups. Okay? And if it's a disease, you need to show us the prevalence. And if it's the outcome, then you need to show us the mean, standard deviation, and the 95% confidence interval. Now, this is just an example, a typical example of a table showing you some characteristics of women who have had preeclampsia. Okay? So you can see these are the socio-demographic features. The first group are women with a preeclampsia. The second group are healthy preeclampsia controls. So this is an unpaired data. It is an unpaired data. So you make the comparison in terms of their age. You look at the age, you have the mean, and we have the mean of each of the ages. Then we have the ethnicity and whatever. Now, look at the education. Then we have the comparison based on chi-square. Okay, you can see none of which is statistically significant. Okay. Hypothesis tests for comparative studies. You have two study groups. Let's say cases and control. Or those who have had intervention and those who have not had it. And you want to test a hypothesis. What do you do? For normally distributed data, the means of the two groups have to be compared using two sample t-tests or two sample z-tests, depending on the sample size. Many a times we use student t-tests when the sample size is less than 30. Now, of course, the two medians are compared. Remember the first one? The first one, we are comparing the means. Now we are comparing the median if the data is skewed. So the two medians are skewed. In that case, you either use Mamutini or you use the Wilkerson sign rank test. However, even if the data is skewed, you can do what you call log transformation of the data. And that will give you the basis to go back and make the data to be normally distributed before you do the analysis. Now, in some cases, you discover that you have three groups to compare. When three or more groups are compared, it is advisable to use one-way ANOVA. So for normally distributed variable, compare three or more means using one-way ANOVA. Now, if the three or more measurements are repeated measures on one group or matched, in that case, you use repeated measures ANOVA. If you remember my graph I showed you earlier. Now, if the data is skewed, it has more than three groups, more than two groups, three or more groups to compare, to be more particular. It is advisable to adopt the Kurzweil tests. And when the three or more groups are skewed, your advisor will tell you that it's better to use the Bradman's test. Now, that's for cross-sectional studies and for continuous data. Now, how about if our study is case control study? If our study is case control study, usually our emphasis lies on the outcome measure. And what is outcome measure in case control studies? Outcome measure are the odd ratios. You remember? Case control studies, we use the odd ratios. Cohort studies, we use the relative groups, right? So outcome measures are odd ratios. Okay? So is what we are looking for. Then we can calculate the crude and adjusted odd ratios to eliminate any effect of any compounder with corresponding p-values. So what you do is, first you have to obtain the crude odd ratio using bivariate statistical analysis, either on SPSS or on theta. After getting the crude odd ratio at bivariate level, Now you do the adjustment. Put the variables into the regression equation. So try to obtain adjusted odd ratio at multivariate level with each of the variables having its own effect. So what happens here is it presents results in a table, and you have a table that have both the crude and the odd and the p-value. Okay? And this is an example of what I was saying. The adjusted odd ratio or the crude odd ratio. You can see some of the variables we measured. This is table 2 from a research on multivariate analysis of the risk factors associated with development of preeclampsia. And after adjustment, okay, you can see how the odd ratios have become. And this is the 95% confidence interval for each of the values after adjustment. Okay. Now, that's for case control. If you are studying case control, I encourage you, try and use odd ratios, get the crude and adjusted. It's a match case control. The analysis needs to identify that you are matching the cases. So if it's a match case control, the appropriate test of statistics is McNeema chi-square. Once you use the McNeema chi-square, depending on the level of your significance set, you should be able to analyze that particular aspect very well. Now, you cannot examine the effect of the match variable as a risk factor for a disease in this match case control. Right. So, what about clinical trials? Because, we have different types of trials. Randomized control, non-randomized control, as the case may be. So, the first thing we do is, in randomized control trials, is we adopt the consort reporting system, which is the consolidated standards of reporting trial system. It's like a prototype of a flow diagram that shows you how many people were enrolled at the beginning, where exposures have been allocated, how the clients have been followed up to the latter, and the analysis of the data. Now, if you are doing a randomized controlled trial, because I've seen some students proposing this type of research as part of their proposal. Now, should eventually you getting the approval, you need to ask yourself some questions. If you want to do randomization, is your randomization effective? And you need to analyze the outcomes to treat process. Okay? Try to present the effects of the treatment in form of with this 95% confidence interval. Do sensitivity analysis, do outcome per protocol analysis, carry out subgroup analysis, analyze the side effects, determine any adverse effects, and secondary outcomes. Now, many times, these are used for drug trials, and you want to determine effectiveness of one drug over the other, or maybe biologicals. For example, you want to determine maybe the COVID vaccine, let's say Pfizer, is more effective than Moderna. So use clinical trial and use randomization as the main procedure there. So this is a typical example of how the process was done using the consort protocol. Yeah. We found a study, and you can see HIV-infected patients were enrolled, and 778 of them I look at the criteria up to the last level at which only 225 remain active follow-up at the end of the study. So you can imagine 68% only remain at the end of the study. Because clinical trial usually takes longer time because you are looking for the effect of that particular intervention, be it a medication or it is an immunologic item, maybe a vaccine or something like that. You need to follow the patients into the future, discover if they develop disease or the disease has been abated, or if there is any side effect that comes with the use of that treatment. Because I told you, you need to adopt the protocol of intention to treat. So this is just like a tabular presentation of the clinical trial I showed you earlier. Okay, so you can see the gender, you can see the age, and as the patient have been grouped into those who have had earlier ART and those who have had later ART, they've been followed, and these are the outcomes. Now, in clinical trial, say there are two phenomena, very important, all three. First is randomization, which we need to be very, very effective. Second is intention to treat. Okay. Now, third one is the one I mentioned. Intention to treat per protocol. So in an intention to treat analysis, you look at the respondents according to their original group of assignment. Are they to receive the intervention or not? Have they adhered to the intervention or not? Alternatively, you can use per protocol analysis instead of intention to treat analysis. But this one is particularly based on actual intervention receipt. There's a criteria for exclusion if it is inadequate or if there is an inadequate adherence to the protocol. Now, the prepared analysis for randomized controlled trial is intention to treat. So, if you want to use RCT for method of statistical analysis is using the per protocol intention to treat. The whole idea is to minimize bias. And because you may likely follow the what do you call them? You may likely follow the clients into the future. Some of them are going to be lost to follow up or attrition. Or some may decide not to adhere to our protocol. So, what am I saying? The summary is, if you are using RCT, just use intention to treat protocol. The outcome measures for RCT are maybe quantitative, which could be the mean outcome, the difference between the means, or a binary in terms of risk difference, in terms of risk ratio, odd ratio, or the rates. That is the number of events per passing years, or the survival time, the number of events per passing years. So these are the outcome measures for RCT. For RCT, just know that this intention to treat, to minimize bias, to address the issues of lost follow-up and loss of what they call adherence. Now I have an example of RCT outcome here. You can see the primary endpoint was survival. Secondary endpoint include tuberculosis. Not too much time here. Now another study, another analysis is survival analysis. This is like you are trying to find out, following a particular event, for how long is the survival of the affected individual. So what is the median survival time? Okay, and this could be presented in terms of the Kaplan-Meier survival curve, or calculated based on hazard ratio, or Cox proportional hazard ratio. Those of you that have had the evidence-based medicine, I think we have discussed survival analysis, which we are able to calculate some median survival time for some interventions. Now, if the study is meta-analysis, the way you analyze the data is also different. We all know that a lot of meta-analysis are being published annually, more than 500,000, as the case may be. So if we are interested in synthesizing or pulling the results of the studies together in the same research, like we do in meta-analysis, it requires you a lot of statistical procedures. So each study we analyze or we want to make a synthesis from, or we synthesize our data from, has a different estimate and magnitude of its effect. So what meta-analysis does is it combines the effects of all studies involved in the meta-analysis. And at the end of the day, you come up with what you call the mean effect. The overall mean effect is 95% confidence interval. Those of you that have attended our, I think, EBM, we have discussed our meta-analysis. We discussed about the heterogeneity of the data, because there are different studies that are pulled together. So the data could be homogeneous or heterogeneous, but many a times it is heterogeneous. So you have to do some statistical manipulation. For example, if there is a little variation between trials, maybe the meta-analysis of trials, and there is a little variation between the trials, you calculate the I-square. Now, if there is significant heterogeneity between the studies you are involved in, it is suggested, or it would be better if you use what you call the random effects meta-analysis. Now, you can also do sensitivity analysis to check if one study has an undue influence over the results you are bringing. So, usually, how do we display results of meta-analysis? We display results of meta-analysis using forest plots. And this is an example of forest plot. I'm sure many of you might have come across it. The line here is called the line of null effect. And the studies that are used in producing this forest plot are to the left side. You can look at it. Smith, John Smith, as the case may be. Now, any study that crosses the line. Now, these horizontal lines presents the confidence interval of each of these studies. So this study, look at this confidence interval. Look at this study. Even this one, look at this confidence. Now, if the confidence interval crosses the line, that means study is not significant. So you can see this particular one. You can see it crosses the line. 1.3, you can see the odd ratio. Oh, this is not the confidence interval. But this is the confidence, this is the line. Once this confidence interval crosses the line of null effect, then it's not significant. Now, another way you can analyze your meta-analysis and present it is use of funnel plot. Now, the funnel plot is another way that tells you much about the sample size used in various studies and the risk ratios. So, in meta-analysis, we are pulling many studies together, trying to bring out one important effect estimate that I will present all the studies. Of course, when you are pulling many studies, the methodologies of those studies are different. Even the data used are different. So there will be variations, and these variations are addressed based on I-square, based on random effects, or based on uh, other statistical manipulation. Now, this brought us to the end of this lecture. So I want to say thank you, and floor is now open for comments, questions, before we run off. Thank you. Question, comments, round up. So the reference we used. Slides. Yes, there is a comment here by one of you. He said, we want a real example in SPSS data. Yes, but real example in SPSS would have been like out of the title you mentioned. If you look at the title, is data analysis, collection and analysis. Okay? Collections, that's the procedure in which you collect the data. And analysis, of course, is not about SPSS. It's how you analyze the whole data. SPSS is just a statistical software which you can use to analyze your data. But we still have time, okay? And I have other slides. Anyone needs, can come forward, and we still have some sessions with some students, I think later this week, on SPSS. So going by the title and going by the SLO, I don't think SPSS belongs here, other than you mentioned. Thank you, Abdulaziz. Question, comments? Okay, over to you, Abdulaziz. Thank you so much for your audience.